then we can get started here. Okay, great. So if you're seeing my screen, you should see question 22. Do you see that?
Yes.
Okay, so a chord, very important, a chord does not go through the center. Like HI is a chord. For example, JL is a chord. J to I is not a chord because it goes through the center. So it's on the circle, but it doesn't go through the center. So that's why that is correct. Is that okay?
Mm-hmm.
Do you want me to write down any more words to that definition, or is the verbal one enough?
If you could write it down, that'd be great.
Absolutely. Okay, so a chord, it starts and it ends on the circle, does not go through the center. So usually you draw something where there's a circle and then there's a chord like that.
Mm-hmm.
Okay, pulling up the next question here. Okay, it says give an example of a major arc. So a major arc is one that has a measure that is greater than 180 degrees. So you got your circle, got a center. So like A, B, and C, that's a major arc there because it goes more than 180 degrees. And usually it's 3 letters, so that's usually an indicator here as well. So let's look at J to L to H. Do you see that goes around this much of the circle? It's more than halfway around. That's a major arc. And you might think to yourself, well, what's a minor arc? Well, minor arc is a measure that's less than 180 degrees. So it would be something that was, say, like from A to B going this way, where it's just part of it, but it doesn't go all the way around more than halfway. All right, I'm going to move on to the next question unless more discussion is needed on that. Okay, this one wants the measure of P to T to Q. So it wants this one here. Do you follow that? Is that okay? Okay, so there's a lot going on here. This 40 on the outside matches the central angle here. So there's a property here that the central angle X degrees equals X degrees here. And this is when it's a central angle. So in the same way, this 120 here is this 120 there on the inside. Now the sum of all the measures, sum of the measures of the angles has to equal 360. Okay, so we have 3 of the 4, so we'll say, I'll just call it T. T plus 120 plus 60 plus 40 has to equal 360. Go ahead and solve that for T, please.
Can you scroll down, please, just a little bit?
Sure.
Okay, thank you. T equals 140.
I agree. So it's that one there. Have you seen this thing with the central angle before?
A little bit.
Okay. All right. 19. Find the diameter and circumference of the circle below. The radius is 8 centimeters. The diameter is 2 times the radius. Okay. Sometimes people write it as the, and I don't know, maybe you can't see that. Sometimes people write this that the radius is the diameter cut in half. Either is fine. They're exactly the same, but in this case, 2 times 8 is 16. That's your diameter here. So that one's out and that one's out. These are okay. Now it also asks for the circumference. The circumference is two formulas, 2 pi r or pi times diameter. They're exactly the same in terms of like they give you the same value, but you have to decide which one you like. So since the radius is given, I'm going to go with that one. 2 times pi times 8, that's 16 pi.
Okay.
Okay, I'm going to move to the next question now. Point G and H lie on circle T so that TH is 8 meters and measure of GTH is 45 degrees. Find the length of GH to the nearest hundredth. Okay, so we got to draw a picture. This could be the hardest part. It truly is an issue. So T is right in the center. I'm just going to arbitrarily put G there, and I don't know where H goes, but I'm just going to put it over here. Okay. Now it says T to H is 8. What's another name for T to H in terms of like what's a word we use to describe something about a circle?
It's a chord. Or
It couldn't go through the center. Like if it went all the way, it's a diameter, but it's just going from the center
the
out to the
radius.
edge. It's a radius, yeah. So it's a
Okay.
radius is equal to 8. That's good to know. G to T to H, well, I need to draw that in. G to T to H is 45 degrees. Okay, now we're trying to find the length of this right here. Do you follow that? Like if we could walk along there and see how far we walk, that's what we're trying to find. So this part around the edge, sometimes you see this formula. You see this formula that says S equals r theta. Maybe you've seen that. Okay, the problem is that you have to know that theta is in radians. And that's sometimes not very helpful. A better way, in my opinion, is to understand that there's a circumference. A circumference is if you go all the way around the circle. That's 2 pi r. Okay, but it's only true if you go all the way around the circle. Are we going all the way around the circle?
No.
No. In fact, we're only going a certain amount around the circle. So the amount that we're going around the circle, that angle, 45, goes there. This angle right there goes there because that's the part of it that we care about. It's a fractional amount. Okay, so if you've been following so far, the circumference, it's not really circumference anymore. It's this S. It's this area along here, this GH is 45 over 360 times 2 times pi, and your radius is 8. Now, it says to just put this into your calculator, so go ahead and give that a shot if you've got a calculator handy. See what you come up with. Just hold on for just a few minutes. There's someone here doing some maintenance work. I'll be back with you as soon as I can. Thank you.
Okay.
Hey, Julia, I'm back. Let me know if you're there.
Okay, I got 50.3.
So none of those answers there. Okay. Did you type in your calculator 45 times 2 times pi times 8 divided by 360?
Yeah.
Okay. Let me try it on my side. Maybe there's maybe I gave you the wrong numbers. Lots of possibilities at this point. I get 6.28 when I do this.
Oh,
Will you try it one more time just to verify that you get that? Because this is an important step.
okay.
I Sorry about that again, Julia. I had a maintenance guy coming into this apartment I'm in. So did you get 6.28?
Yeah, I did.
Great. Okay, let's continue. We're moving at. Are we moving at a good enough speed here for you? I assume you want to get through all of this today.
Yes, I just have a few extra that didn't send.
Okay. I mean, we're definitely. I think we're definitely gonna get through all this. That's why I'm asking. I
Okay.
want to give you more clarity if anything is, not working. So if
Okay.
CW and WF equal and ED equal 30. Where's ED? Okay, ED equals 30. What is the measure of DF? DF. Okay. DF. Okay. Um, this is a property. So if this thing, this bisects that. So EF ends up being congruent to FD.
Mhm.
Uh, and we know that ED is 30. So DF, which is halfway, is going to be 30 divided by 2, which is 15. This is just a straight property. There's nothing sophisticated, special here. It's just a property.
Okay.
But these have to be congruent as well. Oh, I don't see any other options, so I'm not sure what else to recommend. But yeah, is that okay?
Yeah.
All right. Okay. Okay. So next problem here. One of the since we there's a lot of you use a lot of colors here. Okay. Find the radius of circle F. So here's a circle F. The radius is like this right here. Okay. It's also a lot of other things, but this produces a triangle. Do you see that?
Hmm.
Now we know one side is 10, and we know that this whole length is 18. From the previous problem, what is that length there that I'm pointing at? This C to whatever that letter is. Do you recall from the last problem? These are congruent, by the way, these two. And the whole
So
thing is 18. There's no
C to
letter. Yeah, I mean, whatever. We can call it E.
is it 9?
It's 9. And this is where it's really good sometimes to redraw the triangle because the things that we care about, that's 9, that's 10, that's your radius. How do we
Okay.
find the hypotenuse of a triangle? Well, there's Pythagorean theorem. A squared plus B squared equals C squared. So 9 squared plus 10 squared equals R squared. 181 equals R squared. So R equals the square root of 181.
Okay.
So go ahead and punch that into your calculator. Looks like it's this lighter blue one, 13.45. I'm going to try something different on this next one. I want to make the image a lot bigger because I don't think getting doing enough to help you out here on these. So this is the image for the next one, and it wants you to find the measure of arc J to I to H. So whenever it wants the measure, that means the angle. Okay, so now let's review. This goes along with the central angle here. That's 50 degrees. These always match. Whatever they are, they match. Okay. Is that all right? So now they don't say it, but it's safe to assume that J to G is a diameter. This is a diameter here. And that's half a circle. If you go all the way around, how much is it in a circle? How many degrees if you go all the way around in a circle?
360.
360. So halfway around a circle is
180.
180. So this missing one here, I'll call that X. Okay. That X plus 55 plus 50 has to equal 180. So go ahead and solve that for X, please.
75 degrees.
Okay. Now that is not our answer because the answer is, well, I want to go from J to I to H. Which two angle measures does that include? This one, which is 55, and this one, which is 75. So the measure of J to I to H is 55 plus 75, which is 130 degrees.
Okay.
And oh, that is there. I forgot we didn't copy those in. Okay. Okay. Next one here. The next one. Let's see. Let me put this in. Okay, so it asks you to find the length of AB. Okay, so this distance here. Now, I've already done a couple of problems like this. We know that if you go all the way around the circle, that's the circumference. All the way around the circle is 2 pi r. But I said, well, that's true if you go all the way around the circle, and there's 360 degrees in a circle. But we're not going all the way around the circle. How far around the circle are we going?
120 degrees.
120 degrees. Do we know the radius?
4.
Yes. 2 times pi times 4. So we got 1/3 here. So this becomes 8 pi over 3. It says to round to the nearest integer. So go ahead and do that for me.
Um, 8.37.
Okay, and round it to the nearest integer. What would you go with that?
8.
Maybe 8. 8, good. Okay. All right, you said you had a few more to send over? Great, I'll stand by and wait for those.
Okay.
Just checking in here. Did you send over anything yet? Because I haven't seen anything come in.
I'm just waiting on one more to load and then I'll send it.
Okay, great. Email, it's been sent over yet?
Yeah, it's almost done loading. 1 second.
Okay.
Okay, I just sent it.
Okay, checking it over. This is my internet's unstable. We may have some. See if I can connect here. Checking. There it is. Okay. All right. All right, so it came in. Let's just work through these here. Snipping this. And all right, so back to, I'm sharing my screen. In the circle Y, the radius is 34. Okay, that's Y to C. And then AB equals 60. But they just want DC. That's interesting. They just want DC. So the whole thing here is 34. I'm pretty sure that because this meets an 90-degree angle, that these bisect here. So if the whole thing is 34, then this must be just 17 there. Again, that's just kind of a definition. If the whole thing Y to C is 34, then you just cut it in half there. So whenever you see a problem that like doesn't have any sort of rounding, you want to kind of use a little bit of intuition, a little bit of like, well, maybe it's just half, or maybe it's whatnot. So okay, so that now this next question wants you to find Y to D, and again, I think that's the same as this. Not sure how else they expect you to, because this is 34, and we know that this is 60, so that's 30. Yeah, okay. So that doesn't seem right either, but okay. 15. Yeah, okay. Yeah, I mean, again, I think it's just 17. It's these are the same here. Well, I think your teacher might have an error in this question, but okay. 11 here. Are you getting feedback when we do this? I mean, is there anything that's not correct that I should clarify? Or are you just sending these answers off when you're done?
Oh, I was unmuted. No, I understand what's
Yeah,
happening.
anything in error here, because I'd like, okay. All right. This one's just a cool like thing you can do with string, which is if you take the string across the diameter and then you pull it, it doesn't matter whether you pull it there or there. It doesn't really matter where you pull it. These are all 90-degree angles. You can go anywhere like that. So if it goes from a diameter to diameter, but it hits on the circle, it's always 90 degrees. That's number 11 there. That's just a basic property, something that something that you just want to remember for a quiz or test. Okay, it says find the value of Y. Okay, so there's this property here that these across from each other have to be equal, and you may not see why that is, but if I draw the circle without, if I draw two circles here, this 3Y covers this arc, and this 60 covers this arc, and they're the same. Like these two arcs end up being the same. Like they go around. It looks like they even go around at a diameter. So that's how you do that. You say, oh, 3y must equal 60. So y equals 20. Now, do you have the other question here where it asks you to find x? Is that somewhere else, or is that?
I think it's.
Yeah, there it is. It's down here at the bottom. So let's do that one next. Okay, find the value of x. So we already know that this is also 60 here. Okay, the other part is that these other ones must also be congruent. So that's another thing. You just set these congruent to each other. So x has to equal 2x minus 30. So when you subtract x from both sides, and then you add 30 to both sides, you get 30 equals x for your answer. So that image there, let's quickly grab that image here. This image here, okay, so that's 60. This ends up being 60. This is 30, and this is 30. These all add up to 360, and that makes sense for a four-sided quadrilateral. Like that's reasonable. That's kind of the background information there on that one. Okay, let's look at question 8. That's the next one I'm seeing here. Find the value of x here again. So these are congruent again. So I want you to set these equal to each other and see if you can solve for x, please.
X equals 8.
Yep, you got it. All right, we're almost through these. We're almost through these here. Number 7 is next. Number 7 here. It's again, find the value of x. We've talked a lot about this in this class. There's really two things you do. Sometimes you set things equal, and sometimes they add up to something. Here you just set them, you set AB equal to DC. You set this 3x minus 11 equal to x plus 9. So go ahead and try solving that for x, please.
X equals 10.
You got it. Right. Okay, so let's look at number 5 next. Number 5 is kind of like, again, it's one of those where it's like, oh, well, it's either equal to something or it adds up to something. This time it just equals. This x right here has to be related to that 10 there because these are the same. So that means that x is 10. Okay. 6 is the last one that I see that we have to do. Is that kind of what you're saying?
Yes, I sent another email of just like 3 more problems.
Okay, great. Yeah, we'll definitely be able to get through all of these. So here it says 2y plus 1 is, I think, I mean, it looks like it's referring to that one. Oh, maybe it's referring to length. It's got to be referring to length because that's 90 degrees and that wouldn't work out. So these are congruent. So that y plus 4, has to equal to the 2y plus 1. Similarly, 3x minus 4 has to equal 5x minus 18. So go ahead and solve those. I'm going to be right back with you, maybe 60 seconds, but we'll get through all of this, okay? Julie, I'm back here. Did you come up with an answer for X and Y?
Y equals 3 and X equals 11.
Yep. So, no. On this one over here, when we add 18 to both sides, we subtract 2x, we get 14 here, and sorry, 3x and 3x and 2x here. So x equals 7, y equals 3.
Oh, okay.
Is that okay?
Yeah.
All right. Okay, on to the other email here. I see question 4. We're going to go through, we're going to find the measure of angle PRQ, P to R to Q. So this angle right here is what we're trying to find. Do you remember what this angle up here is from a previous problem? It's always something. This one's always,
90.
it's always 9 degrees, yeah. So if we know that angle, we know that 39 plus 90 plus R has to equal 180 because all the angles in the triangle must add up to a 180. So R ends up equaling 51 degrees. All right. Okay, we're gonna do number 3 next. Really should have done these in order. I mean, it would have been a little better for learning, but I know we got through them all. But there's some things here we could definitely clarify. So the image up here, this is not a central angle; it's an inscribed angle. So whenever the angle is here, if that's x, this is 2x, and this is called an inscribed angle. Okay, so the relationship is that whatever it is in here, doubling this to 7x plus 9 gives you the 46. So 46 is going to equal the doubling of 7x plus 9. Okay, so to solve this, you divide both sides by 2. You get 23 equals 7x plus 9. Subtract 4 from both sides. I'm sorry, subtract 9 from both sides. And you get 14 equals 7x. Divide by 7, so x equals 2. And the last two are pretty much the same, but they're, I think, a little bit more straightforward. These are the ones that are good to do kind of initially. There's 2 ways you can remember it. You can either remember that the angle on the the angle on the outside is double it, or the one on the inside is half. And I mean, they're the same, but like in this picture, x is half of 102. So that ends up being 51 degrees. So either what x is half of 102 or 102 is double whatever x is. All right, so if that was clear, let me snip the last one here. It's the same type of question. See if you can do this one on your own. Same idea here, same type of problem. Let me snip this in. All right, so let me know when you get an answer for this one, please.
I got 67.
It should be double, right? 68.
Oh, yeah.
34. 2 times 34 is 68 degrees. All right, this is a great place for us to stop. Thanks for scheduling, and I will send out the notes and the screen recording here shortly.
Okay, thank you. Thanks for
See you next
seeing
time.
me.
You're welcome. Bye now.
Bye.